Hi guys, welcome back to the second day of Atomic Science from home. I hope everything went smoothly yesterday and you completed all the work that you were assigned. Remember, if you've got any questions, send me a message. I can see quite a few of you have done the work in Education Perfect, which is awesome. Today we're just going to start off with a little bit of a recap of what we looked at yesterday. So here is a model of an atom. And as you can see in the middle here, we have the positive protons and the neutral neutrons. And they are grouped together in the middle of the atom in a thing called the nucleus. Now, the nucleus contains about 99.9% of the weight of the atom. Around the atom, quite far away, we have the negative electrons orbiting around them. And in between the nucleus and the electrons is just plain empty space, which actually makes up most of the space of the atom. What we looked at after that was the periodic table, which is here, and what these numbers mean on them. So here we have hydrogen, it's got a 1 and a 1, helium, a 4 and a 2. The first thing to remember is that the biggest number is going to be the mass number. Here they call it the relative atomic mass. And the smaller number is going to be the atomic number. What do these numbers mean? So the atomic number, or the smaller number, is equal to the amount of protons in the atom and also equal to the amount of electrons in a neutral or uncharged atom. The other number, 12, or the mass number, is the number of protons plus neutrons. So the way to work out the amount of neutrons is we get this number, 12, and subtract from it the number of protons we have, which is 6. The big number minus the small number is going to equal 6, so we get 6 neutrons. So in carbon we have 6 protons, 6 neutrons, and 6 electrons. What we're going to be looking at today are what those electrons do. They're a little bit different. They orbit around the nucleus. So here is a diagram of the atom again, and we can see the electrons orbiting around the nucleus. In this diagram, however, all of the electrons look like they're about the same distance away from the nucleus. And in this diagram, it looks like there's only one electron per orbital or circle. In reality, it's a little bit different. So here is a more accurate diagram of an atom. In the middle, we have the nucleus, and then we have these orbitals or circles around the nucleus where the electrons exist as they go around the nucleus. Each orbital has a maximum amount of electrons it can hold. The first shell or orbital can only hold 2 electrons, the second orbital can hold 8 electrons, and the third orbital can hold 8 electrons as well. We're going to only be dealing with the first 3 electron shells or orbitals, so don't worry about the fourth one. And orbitals, shells, they mean the same thing. So electrons in an atom orbit the nucleus in rings. These are called electron orbitals. Each orbital can hold a specific number of electrons. When we add electrons to our atomic diagram, start filling orbitals from the innermost, this one here, and when that one is full, move on to the next orbital. So let's show you, I'll show you how that's done. So first one we're going to look at is helium. So if we want to draw the electron orbitals for helium, first we've got to find it on the periodic table. You've got one at the back of your book. And there it is, 4, 2. There's the atomic symbol, He, and that's the name. So first we have to work out how many electrons it's going to have. It's got an atomic number of 2, so it's just going to have 2 electrons. Now, the first shell of the electron diagram remember, can hold a maximum of 2 electrons. So those 2 electrons are just going to sit in the first shell. It's now full. So to write the electron arrangement of helium, we just say it is 2. Very simple. For carbon, it's got an atomic number of 6, so it's going to have 6 electrons around it. The first 2 electrons are going to go into the first electron shell here, but we still have 4 more left over, so those 4 are going to go into the next electron shell. So here we got 2 in the first shell, 4 in the second, so the electron arrangement is 2, 4. And the last one here we got is sulfur. It's a bit bigger. It's got an atomic number of 16, so it's got 16 electrons. So the first 2 are going to go on the first shell. The next shell can hold a maximum of 8. So we're going to put the next 8 in there. So 2 plus 8 is 10. We have 6 more left over, so those 6 are going to go in the next outermost shell. So remember, start filling from the from the innermost shell to the outermost shell. So here we've got the electron arrangement of 2, 8, 6. Like that. All right, before we were talking about the amount of electrons in an atom, and we said it was equal to the atomic number in an uncharged atom. Now, atoms can become charged by losing or gaining electrons. They generally give it to another atom. So, if an atom is uncharged, it means it has the same amount of electrons and protons. Remember, electrons are negative and protons are positive, so we've got the same amount of each. They're going to cancel each other out and be neutral or uncharged. However, if an atom gains an electron, it will then become negatively charged because electrons are negative. It's got more negative electrons than positive protons. If the uncharged atom loses an electron, it will then become positively charged because it's got more protons than electrons. So, atoms are most stable when they have a full outer ring. This can be achieved by losing or gaining electrons. If the atom has 5 or more electrons, it will generally gain electrons to get a full shell, so it can have 8 in its outer shell. If it's got 3 or less electrons, it will generally lose electrons to get a full outer shell. So let's look at these ones we had before. Helium 1, 2. It's got 2 in its outer shell. So that one is already full. It's got a full outer shell. This one here, sulfur, it's got 1, 2, 3, 4, 5, 6 in its outer shell. It wants to get a full outer shell, so it is going to gain 2 more electrons. If it gets 2 more electrons, it will then have a full outer shell. So here is sodium. Sodium has an atomic number of 11, so that means it's got 11 electrons going around it. If it wants to get a full shell, it can, because it's got 3 or less electrons in its outer shell, it can lose this 1 electron. That electron goes away, and then it's got 1, 2, 3, 4, 5, 6, 7, 8 in its outer shell, because this one is now the outer shell, yeah, because that electron's gone. It's got a full outer shell, so now we can call it stable. However, because it's lost one electron, we now have 11 protons and 10 electrons. Because we have 1 more positive proton than electron, we say it has a charge of 1 plus. So when we write the formula for it, we say Na plus. We call this an ion because it has lost or gained, it's lost an electron. So anything that's lost or gained electrons is called an ion, and it will have a charge. Here's another example, sulfur. Sulfur has an electron arrangement of 2, 8, 6. So it's got 16 electrons, 2 in the first shell, 8 in the second, and 6 in the third. To get a full outer shell, because it's got more than 5 electrons, it needs to gain 2 more electrons, here and here, and now it's got 8 electrons in its outer shell. It now has 2 more negative electrons than positive protons. Go away. And that means it's got, it's got 2 more negative electrons and positive protons, so it has a charge of -2. And the way we write the symbol for the ion now is S for sulfur and a little 2 minus. If you look on the far right hand side of the periodic table, where are we here? We have helium, neon, argon, krypton, xenon. These are special elements because they naturally, or uncharged, have a full outer shell. So all group 18 elements, the ones on the far right, are known as noble gases, and they have a complete outer shell. So here's helium, it's just got 2 electrons in its first shell. Neon, it's got 10 electrons, so 2 in its first shell, 8 in its second. Argon, 2 in its first shell, 8 in its second, 8 in its third. So they all have complete outer shells. What this means is they don't want to gain or lose electrons, so actually they are very non-reactive. Have you ever seen the Hindenburg disaster? What that was a big airship that was filled up with hydrogen. Now hydrogen does not have a full outer shell. It's very light, so it's good for lifting up these big airships, but it's also very reactive, so when it hit something it caught on fire and burnt up really quickly. What they use now instead of hydrogen in these airships is helium. It's the second element in the periodic table, so it's still very light, so it's light enough to lift up the airship, but it's not reactive at all. So you can't light it on fire, it's not going to burn, it's completely safe to use. All right, I'm going to direct you to what work you are going to be doing today. So in your Scipad, go away. In your Scipad, you are going to be doing this page here, 14, 15, and 13, just pages 14 and 15 today in the Scipad. And then for Education Perfect, I've been logged out, but I will, for Education Perfect, I will assign some work for you to do as well. Remember, if you don't have the Scipad, I can send you an electronic version. Just send me an email. And if you have any other questions, just send me an email as well. Tomorrow, I am going to be sending out an invite for my 2 classes, 10S and 10H, for a catch-up on Google Meets. It's probably going to be at 12 o'clock for one class and 2 o'clock for the other class. I'll send you invites though to let you know when it's happening. Alright, so that's all for today. Hope you enjoy this homeschooling, and I'll give you a message tomorrow. Thank you.